Hi, my name is Evelyn Mesler, and I'll be solving problem 39 from chapter 14 on page 665 of your chem textbook. The question reads, a reaction in which A, B, and C react to form products is first order in A, second order in B, and zero order in C. A, write the rate law for the reaction. The rate law for any reaction is defined as the relationship between the rate of reaction and the concentration of reactant. While we are not given the concentration of reactants, the problem does give us the rate of reaction for each variable. The rate of reaction here is A is first order, B is second order, and C is zero order. Use the orders as exponents in your final rate reaction, as seen on the right. K times the concentration of A to the first order times the concentration of B to the second order times the concentration of C to the zeroth order is your rate law. B, what is the overall order of the reaction? The overall order of any reaction is the sum of exponents in the rate law equation. So here the exponents are 1, 2, and 0. 1 plus 2 plus 0 equals 3, which gives you your overall order. C, by what factor does the reaction change if A is doubled and the other reactant concentrations are held constant? Your original rate law, you compare that to your modified rate law. So the original rate law is K times the concentration of A to the first times the concentration of B to the second times the concentration of Z to the zeroth power. Modified, all I did was substitute 2A in for A because the rate is doubled. Then you distribute the exponential of 1 to both the 2 and the A, giving you 2 times the concentration of A to the first power, and then substitute that in for your modified equation written here. 2, got from here, times your original equation. Then when you compare them, you see that everything can be crossed out, K's, concentration of A, concentration of B, concentration of C, except for your 2. Therefore, the rate changes by a factor of 2. D, by what factor does the reaction rate change if the concentration of B is doubled and the other reactant concentrations are held constant? This is very similar to C. You compare your original rate law to your modified rate law. In my modified rate law, instead of replacing 2A, I replaced 2B because the concentration of B is doubled. And then I distributed the 2 to both the 2 and the B, giving me 4 times the concentration of B squared. When you compare that to your original rate law, the only thing that's outstanding is your 4. Therefore, this doubling the concentration of B changes the equation's rate by a factor of 4. E, by what factor does the reaction rate change if the concentration of C is doubled and the other reactant concentrations are held constant? Here, it's important to know that anything to the first power is always equal to, or anything to the zeroth power is always equal to 1. So the concentration of C to the zeroth power is equal to 1, and the concentration of 2C, or the concentration of C is doubled, to the zeroth power is equal to 1 as well. So when you compare your original rate to your modified rate equation, original rate, modified rate, you'll just be multiplying this by 1 both times. And multiplying by 1 doesn't change, so the reaction will not change if C is doubled because this is equal to this. F, by what factor does the reaction rate change if the concentrations of all reactants are doubled? Look at your original rate law and look at your modified rate law. I just substituted in 2A, 2B, and 2C because everything is doubled. Then, just as we've been doing, you distribute your exponent. So 2 to the first is 2, A to the first, A to the first, 2 squared, 4, B squared, B squared. Anything to the 0 is always 0, or is always going to be 1. So then the only thing different between this equation and this equation is 2 times 4, which means that the whole thing changes by a factor of 8. As a summary for this problem, we began by finding the rate law equation using orders as exponentials. We then found the overall rate of the equation by adding up individual rates. And finally, we worked on predicting altered rates by comparing original rate laws to modified rate laws.